Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing probability trees. In this question, we are told each morning the probability that it rains is 2 over 3. If it rains, the probability that Asha walks to school is 1 over 7. If it does not rain, the probability that Asha walks to school is 4 over 7. Complete the tree diagram. So the first thing you should know about tree diagrams is that the sum of any two branches must equal 1. So we can immediately realize that this is 1 over 3, and this here is 6 over 7. We simply subtract the other branch from 1. So we do 1 minus 2 over 3 or 1 minus 1 over 7, and we get these values. We're also given this value here, which is the probability that she does not walk to school. Excuse me, it's the probability that she walks to school given that it does not rain. So this is 4 over 7. And therefore, this value here would be 3 over 7. This is the completion of the tree diagram. B says find the probability that it rains and Asha walks to school. So the probability that it rains and Asha walks to school means that we want to tread down this path here. It rains and then she walks to school. So we multiply these two numbers together, and that is going to give us the final answer. So 2 over 3 times 1 over 7. This gives us 2 over 21 as a final answer. In CI, we are required to find the probability that Asha does not walk to school. So Asha will not walk to school here and here. And we need to get the probability of these two together. So for the first one, for the top one, the path looks something like this. It rains and then she does not walk to school. So we multiply 2 over 3 by 6 over 7. So it will rain and she will not walk to school. So we multiply because we said and then the answer here would be 12 over 21. And then for the second scenario, it does not rain and she does not walk to school. So we need to multiply these two values together. So 1 over 3 times 3 over 7. And this gives us 1 over 7. So either this would happen or that would happen. So therefore, the final answer is going to be 12 over 21 plus, since we said or, so 12 over 21 plus 1 over 7. You can use your calculator or you can just simplify here by dividing by 3. You get 4 over 7. 4 over 7 plus 1 over 7 gives us 5 over 7 as a final answer. And here, this is the final answer to the previous question. Let's just put circles around our final answers here. Now, in double I, we are required to find the expected number of days that she does not walk to school in a term of 70 days. So the expectation is the probability times the number of occurrences. So 70 times 5 over 7, and this will give us 50. In D, it says find the probability that it rains on exactly one morning in a school week of 5 days. So we have 5 days, and we want it to rain once and not rain on the other days. So for example, rain and then not rain, not rain, not rain, not rain. So this scenario is basically 2 over 3 multiplied by 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3. And this scenario could happen in 5 different ways. So we can have the R here, or we can have R here, or R here, and so on and so forth. So in the second scenario, it would be R dash, R, R dash, R dash, R dash. And then in the third scenario, everything would be R dash except for the middle item, and so on and so forth. So you have 5 different ways of achieving this. So we multiply our answer by 5. And therefore, we can use the calculator to find this. We have 10 in the numerator. And we have 5 threes, so 3 power 5 in the denominator, or you can just use your calculator. you're going to end up with 10 over 243 as a final answer. So 1 over 3, 6 over 7, 4 over 7, and 3 over 7. And then we have 2 over 21 as the correct final answer here for B. And then we have 15 over 21, which is the same as 5 over 7, of course, and then 50, and then 10 over 243. So the answers seem to be correct. In this question, we're told the probability that it will rain tomorrow is 5 over 8. If it rains, the probability that Rafael walks to school is 1 over 6. If it does not rain, the probability that Rafael walks to school is 7 over 10. Complete the tree diagram. So the probability that it rains is 5 over 8. So we can put 5 over 8, and we can put here 3 over 8. And then if it rains, the probability that he walks to school is 1 over 6. And this tells us that the probability that he does not walk to school is 5 over 6. And then if it does not rain, the probability that he walks to school is 7 over 10. So the probability that he does not walk to school would be 3 over 10. In B, we are told calculate the probability that it will rain tomorrow and Rafael walks to school. So this is the path that we want to take. Therefore, the probability is 5 over 8 multiplied by 1 over 6. And this gives us 5 over 48. In C, we are told calculate the probability that he does not walk to school. So we have two scenarios. Here we have does not walk, and we also have does not walk here as well. We want to calculate the probability of each and then add them up together. So the probability of the upper one is that it rains and he does not walk. So this would be 5 over 8 times 5 over 6. And this gives us 25 over 48. And then the probability that he does not walk in the other scenario is achieved by walking down this path here. We have 3 over 8 and 3 over 10. We multiply 3 over 8 by 3 over 10. And we get 9 over 80. So these are the two possible scenarios. And then we add them up. And we get 25 over 48 plus 9 over 80. You can use your calculator to figure this out. And the final answer would be 19 over 30. So B is 5 over 48, and C is given as 304 divided 480. And this is the same as 19 over 30. So we seem to have obtained the correct answers. Tanya plants some seeds. The probability that a seed will produce flowers is 0.8. When a seed produces flowers, the probability that the flowers are red is 0.6, and the probability that the flowers are yellow is 0.3. Tanya has a seed that produces flowers. Find the probability that the flowers are not red and not yellow. So the probability that they are red is 0.6. The probability that they are yellow is 0.3. So the probability that they are neither red nor yellow would be 1 minus 0.6 plus 0.3, which is 0.9 here. So 1 minus 0.9 gives us 0.1. Now we want to complete the tree diagram, so we can just write here 0.2, 1 minus 0.8. And then for red, we write 0.6. For yellow, we write 0.3. And for other colors, we write 0.1. In double I, we're asked to find the probability that a seed chosen at random produces red flowers. So it must produce flowers, and then they must be red. So we're going to thread down this path here. So 0.8 times 0.6. And this gives us 0.48 as a final answer. In triple I, we're told Tanya chooses a seed at random. Find the probability that this seed does not produce red flowers and does not produce yellow. So it will either not produce anything at all, or it will produce other colors. So we have 0.2 here. There is nothing else to write. Or we have the other path, which is that it produces something other than red and yellow. So this is 0.8 times 0.1, which is 0.08. And we add this to 0.2 and we get 0.28. So the final answer here is 0.28 as a probability. In C, we are told two of the seeds are chosen at random. Find the probability that one produces flowers and one does not produce flowers. So we have two scenarios. Either the first one produces and the second one does not produce, or the first one does not produce and the second one produces. So 0.8 times 0.2 plus 0.2 times 0.8. And this gives us a total of 0.32 as a final answer. So let's check the marking scheme. We have 0.1 for A, and then 0.2, 0.6, 0.3, 0.1 for BI. We have 0.48 for BII, 0.28 for triple I, and 0.32 for question C. On any Saturday, the probability that Aaron plays football is 3/4. On any Saturday, the probability that Bob plays football is 2/5. Complete the tree diagram. So the probability that Aaron plays is 3/4. Probability that he does not play would be 1/4. And then for Bob, we have 2/5, 3/5. And it is not affected by Aaron, so we just write the same numbers here again, 2/5 and 3/5. In double I, we're required to calculate the probability that both play football. So for both to play football, we want this path here. So we have 3/4 times 2/5. And this gives us 3/10. For triple I, we want the probability that either Aaron plays or Bob plays, but not both. So we have either Aaron plays and Bob does not play. So we have these two numbers together. So 3/4 times 3/5. Or we have that Aaron does not play, but Bob plays. And in this case, we're going to multiply these two numbers together. So 1/4 multiplied by 2/5. And we evaluate this expression. So we have 9/20 for the first one. We have 1/10 for the second one. So we get 11/20 as a final answer. In B, we are told calculate the probability that Bob plays football for 2 of the next 3 Saturdays. So we have 3 Saturdays. We want 2 of them to be successes. So the probability that Bob plays is 2/5. Let's call this S. So probability of S is 2/5. Probability of S is success and S dash would be failure. So this would be 3/5. So we have either S, S, S dash, or we can put the S dash in any other position. We can put S dash in the middle, or we can put S dash at the beginning. So there are 3 different ways in which we can position S dash. And in each case of these, the probability is 2 S's and 1 S dash. So you have 2/5 times 2/5 times 3/5. And then there are 3 ways that this could happen. So we multiply this answer by 3. And we can use the calculator to evaluate. We're going to get 36/125. When Aaron plays football, the probability that he scores the winning goal is 1/7. Calculate the probability that Aaron scores the winning goal one Saturday. So he needs to play. So the probability is probability of playing and scoring. And this is the probability of 3/4 multiplied by the probability of 1/7. This gives us 3/28 as a final answer. Now let's check the marking scheme. So we have AII is 3/10. And this is correct. This was our answer here. And then AIII is 11/20. B is 36/125. And C is 3/28. So we seem to be in line with the marking scheme. Here we are told the probability that the school bus is late is 9/10. If the school bus is late, the probability that Seb travels on the bus is 15/16. If the school bus is on time, the probability that Seb travels on the bus is 3/4. Find the probability that Seb travels on the bus. So here we have two events that are chained together. So it would be nice to draw a probability tree to represent this. So we can have late and not late, and then bus and not bus in each case. Now the probability that the school bus is late is 9/10. So this here is 9/10 and this here is 1/10. Now, if the school bus is late, the probability that he uses the bus is 15/16. So therefore, the probability here is 1/16. And then if the school bus is on time, the probability of using the bus is 3/4. Now, this is 3/4, and therefore this is here 1/4. We want the probability that he travels on the bus, so we want these two events together. We're going to add them up together. So for the first event, we have 9/10 times 15/16. And you can use your calculator to figure this out. You get 27/32 plus the second event, which is that the bus is not late and he uses the bus. So 1/10 times 3/4. And this gives us 3/40. So we add these two together. And we get a final answer of 147 divided by 160. And this is the correct final answer here. Harris is taking a driving test. The probability that he passes the driving test at the first attempt is 0.6. If he fails, the probability that he passes at any further attempt is 0.75. Calculate the probability that Harris passes the driving test at the second attempt. So this is a Bernoulli trial. It's not really a probability tree, but it can be represented as a probability tree in order to better visualize. So let's take test one. So for test one, we have T1, for example, and T1 dash. And then we have T2 and T2 dash in each case. So T1 is test one passed and T1 dash is the failure. T2 is the passing of test two. T2 dash would be the failure. You can even extend the tree further. You can have T3 and T3 dash for each scenario like this. It's just for your understanding. You don't really have to do this in the exam, but it's just a way to understand how this experiment works. So the probability that he passes at the first attempt is 0.6. So this is 0.6 and this is 0.4. If he fails, the probability that he passes at any further attempt is 0.75. Now, if he passes T1, there is no reason for him to take the test again. So you don't actually need this part of the tree, or this part, or this part. Because once he passes, he stops doing the experiment. So this is how this is different from a regular probability tree. Now, if he fails, the probability of passing the second attempt is 0.75, and then failing would be 0.25. Again, if he passes, you do not really need this branch anymore. If he fails, he can take the test again, and the probability would still be 0.75 in passing and 0.25 in failing. So in A, we want him to pass at the second attempt. So in order to reach the second attempt, he must have failed his first attempt and then passed his second attempt. So therefore, the values we're looking for here are 0.4 and 0.75. So we simply multiply 0.4 by 0.75. And we get 0.3 as a final answer. In B, we want the probability that he takes no more than 3 attempts to pass the driving test. So there are 3 scenarios for this to occur. He can either pass on the first time, or he can fail on the first time, but pass on the second time. So T1 dash and T2. Or he can fail on the first time, fail on the second time, and then pass on the third time. So these are the 3 scenarios that we have. So scenario 1 is just T1, which is the 0.6. And then scenario 2 would be failing on the first attempt, but passing on the second attempt. So 0.4 and 0.75 together. So this would be 0.4 times 0.75. And then for the third attempt, he would have to fail both the first and the second. So 0.4, 0.25, and then he would pass the third attempt. So 0.75. So now we have 0.4 times 0.25 times 0.75. And we add these up. So we have 0.6 and then 0.3 and then 0.4 times 0.25 times 0.75. This gives us 0.4 times 0.25 times 0.75 gives us 0.075. So therefore, the answer would be 0.975. This would be the final probability here. 0.3 is correct, and 0.975 is also correct. In this final question, we're told another bag contains 5 blue marbles, 2 green marbles. Brian picks 1 marble at random without replacement. If this marble is not green, he picks another marble at random without replacement. He continues until he picks a green marble. Find the probability that he picks a green marble on his first, second, or third attempt. So this is quite similar to the driving test question. He can either pick blue or green. If he picks green, he stops. If he picks blue, he starts again. He can pick blue or green again. And then if he picks blue for a second time, he would have to take a third attempt. And we stop after 3 attempts because this is the scope of the question. So for the first one, we have 5/7 for blue and 2/7 for green, because we have 7 marbles in total. Once he picks a blue marble, we have 6 marbles in total, 4 of which are blue. So here this is 4/6, and this would be 2/6. And then if he picks another blue marble, he gets 3/5 here and 2/5 for green. Now, he can either pick green on the first attempt, or he can fail on the first attempt, but pass on the second. or he can fail on the first two attempts and then pass on the third. So for the first attempt, green would just be 2/7. Blue-green would be 5/7 times 2/6. And then blue-green would be 5/7 times 4/6 times 3/5. Excuse me, this is here 2/5. And finally, we simplify and we add. So we have 2/7 here. And then 2 and 6 gives us 1 and 3. So we have 5/21. And then here we can cancel out the 5s. And 2 and 6 gives us 1 and 3. So we have 4/21. So the total would be 15/21, which is 5/7. And this would be our final answer. And this seems to be correct, which brings us to the end of our video. I hope this has been beneficial. Thank you for watching.